question.
Yeah, the first part. The second part was that if we were to find that evolution was not true, do you feel like that would be considered evidence for or a confirmation of your religious belief?
I think when we're comparing models, for example, evolution, I would say, obviously the Bible teaches, and it says it many times in Genesis, that the animals, the living organisms, they're going to bring forth after their kind. So I believe there's going to be strong variation within the gene pool of organisms. So that would be my starting point in a young Earth creation model. Evolution would say that we all descend from a single or obviously maybe multiple common ancestors, universal common descent. I call that pond scum to people evolution, which kind of it'll say that a single-celled life form, and obviously I don't want to give a straw man here, but I'll try and put it in a nutshell, gave rise to obviously more advanced life forms. And over the millions of years, I mean, correct me if I'm wrong, increases in genetic information caused by mutations, natural selection. That is technically, where all the life forms we see today. So for that to be true, I'd have to see, a gain in new information, say within the organism's genetic material, in order to, for it to evolve into, I guess, from a young Earth creationist standpoint, another kind. So if I'm comparing biblical models, the fact that I believe evolution isn't true kind of affirms my belief in the biblical model that they'll bring forth after their kind, and that's what I believe empirical science points to. Okay,
I mean, so like the talk of models there is interesting. So again, like I don't want to to straw man your position here, but I'm assuming you are of the belief that there was a global flood, a bunch of animals packed onto a boat, washed up on a mountain, came out, repopulated the world. Essentially, you believe in a literal reading of the Noah's Ark story, right?
I believe in a literal reading of the biblical text. That means if there's a metaphor or a simile or something like that, how it says that, God has wings and he's going to come for you. Obviously, literally, he doesn't have wings, but literally that is, a metaphor. So I take it literally when it has to be. So yeah, I believe in a global flood. I believe that explains, all the geology we see around us. So yeah, definitely.
Mm-hmm. Now, what do you mean by geology? What kind of geology?
That's how I would explain just everything we see around the world, all the fossils, billions and billions of dead things. Fossils require things to be buried quickly. Just various.
Yeah. The flood model that you're talking about, like when we talk about, again, observable things that we can see through like the fossil record. Yeah. So when we see noticeable layers of simpler life forms becoming more complex as they grow higher in the layers. Sure. Now, how would that be something that is like predicted upon in your model? Like, I guess you could say that well, no, just go with that. Yeah, you have simpler life forms. Obviously, there at the bottom, then they start getting more complex. Then you up to the point where you get dinosaurs and whatever. Keep on going higher, and then you start getting your first kind of more mammals, and leading up to where we are now. It seems that there's a pretty accurate model for why we'd see that on any type of old Earth viewpoint, but the very neat, concise sorting that's consistent around the world of things, and it's not necessarily by size, like animals that you'll find, especially when you get to the things like the layers with dinosaurs, are huge in size compared to later layers, where you might see smaller things. But the things that come before the dinosaurs would also be smaller things. So they're not being sorted by size; they're actually being sorted by complexity. And I don't understand any type of mechanism that sorts by complexity.
Sure. Yeah. So obviously here we're dealing with, I guess as Ken Ham would say in the Bill Nye debate, I'm sure it's not the first time you've heard it, but operational science versus historical science. So obviously, we have the same evidence, the same facts that we're interpreting. And I understand that, you look at the Precambrian layer, the Cambrian, and all the different Jurassic, Triassic, all the different layers. You got the more simple life forms. I mean, I wouldn't consider a trilobite, simple by any means, especially the complexity of its eye. these types of organisms at the bottom, in the Cambrian layer, moving its way up to obviously fish, amphibians, reptiles, mammals, and then us at the top. But I think the biblical flood model perfectly predicts the fact that you'd expect to find humans at the top. Obviously, for functional reasons, they're going to escape the waters as long as possible. They're going to be buried last, and at the end of the day, if they're buried last near the end of the flood, they're not going to fossilize. They're going to bloat. They're going to float to the top.
But that would assume some type of there's always the one that gets left behind. The old guy, the guy that's crippled, the children that might be abandoned by their parents. There's a lot of things that we can point at that way. In the case of something like a global flood, it's entirely possible that you'd see children and old people on the bottom layers because they might not be able to escape with some of the adults. Even within that, to say something like, oh, well, all humans would be we'd expect to see them on the top layer because they'd all escape. Well, no, in reality, we wouldn't expect to see that. We'd expect to see them mixed within the layer, depending on the capabilities that they had to escape. So, just even a statement like that just doesn't actually have any type of reflection over how we see, these things as they would play out.
Well, if you look in Genesis, God created two people, Adam and Eve, and a lot of animals. Therefore, you're going to expect to see a lot of animals in the fossil record. You're going to expect to see very few humans. If you got 2 humans populating and you got, millions of different animals populating as well, at the same time, I'm sure we can agree that fossils are found in fragments. Very rarely do we find, a fully formed fossil, of a fully formed animal at the end of the day. If there are humans buried deep, if you actually do the calculations of the size of the Earth, the very few that might be found in the deeper layers, the chances of finding them are slim. I think, evidence of the negative isn't really evidence at all. I would expect birds to be found at the top. Obviously, they're going to fly the longest. And the things we find at the bottom, trilobites, clams, these types of things, fish. These are things in a global flood, because Genesis says that the fountains of the great deep broke open. And if you actually imagine that, those types of animals are definitely going to be the ones to bury first. But I would say, according to your model, if we're going to start off as, a single-celled life form, gives rise to more advanced life forms, and your mechanisms, mutations and natural selection, where's this new information coming from? Obviously, if an amoeba is going to evolve into something,
Sure. Okay. Let's. Again, I don't like being pushed into the evolution talks too much, but for the new information that's being processed there, what do you think when you talk about new information? What are you referring to in this kind? For something like that, what would be an example of new information?
Okay, well, obviously we know that our information system is made up of the DNA, symbolized by the letters GCAT. And at the end of the day, if you look at the alphabet, a book, it's made of information. If you have
but I'm not sure. I understand that. I'm more kind of looking towards the idea of
Are you wondering what information is is because I'm trying to give you the definition of it, but I
just in the case of new information, you can take a look at the DNA of something. You can take because obviously you've heard people talk about evolution being a change in allele frequencies. And so in that case, there you know that exists. You know that we can observe this change in allele frequencies. So you're obviously not considering that as a form of new information. So I guess so when you're looking at these things now, if you take a look at DNA, what are you looking at that would constitute as new information within the DNA itself?
So if I'm looking at a gene pool, and I agree evolution would be defined as change in allele frequency over time. Obviously in populations, not individuals are evolving, but populations are evolving, but populations are made of individuals. From what I see with mutations, obviously mutations are permanent changes in the DNA strand. And virtually all these observed mutations, you can safely put them in the category of loss of information and not a gain of function. So I would say that new information would have to be existing information that wasn't there before. Because if I have information, say, in a dog population, okay, you're going to get a bigger dog, you're going to get a small dog, thick fur, thin fur. At the end of the day, there's going to be incredible variation in that gene pool. Change in allele frequency, you're going to get a whole variety of dogs, and we see that with artificial selection.
And sorry, you said that that's a loss of information, though.
So a loss of information. So if you're looking at mutations in general, what we do see is genetic entropy. We're seeing information degradation. So obviously we're not going to get rich by losing money.
Sorry, what do you mean degradation? Like, can you give me an example of what you mean by degradation?
Sure. So for example, let's say a beetle. Okay, if I know there's a certain environment where winged beetles lost their wings. And now it's beneficial. Okay, so it's a mutation that's beneficial because now the beetle's not going to get blown out by the wind. But at the end of the day, there's no new information because that beetle lost the information for wings. So that's not an uphill change. That's not a gain of function. And all known examples of mutations and natural selection acting on the mutation, because natural selection is a selection process. If you take the example of the dogs, okay, change in allele frequency over time, all you want, you're going to get a dog. I mean, you're going to get, I would agree, a wolf, a coyote, a fox, a domestic dog, they all probably share a common ancestor, and it was a dog. As Ken Hovind would say, dogs produce dogs. At the end of the day, if you go, deep into the genetic information system, it's because that information is limited to that dog gene pool. You're not going to get anything other than a dog. And I know dogs don't turn into cats, dogs don't turn into whales. But at some point, there must have been some big change. And if these animals, if there's no new information, I don't know if you understand what I'm saying, but do you believe the dog we see today came from a non-dog, a population of non-dogs, say millions of years ago? Would you agree with that?
Yeah.
Well, and where's the evidence? If we see dogs producing dogs, but you're saying a dog today came from a non-dog, long ago and far away, millions of years ago, how is that observational science? Because I need to see the new information. All I see is a variation of dogs. I see no new information.
Okay, so I guess first off, the idea that because you did throw this in there for a quick second, that because I believe that the population of what we call dogs nowadays came from something that wasn't a population of dogs, that somehow in the future it's going to cease to be a population of dogs as well, and there's going to be something else. Well, that's not the case. It's a population of dogs now. It's always going to be a population of dogs.
But you did say they came from a non-dog.
Yeah, of course.
Okay.
Yeah, so, but that's a fundamental point, is that you never stop being what you were, but new stuff does get added onto it. So new stuff.
The law of monophyly. Yeah, no, I agree with that.
Okay, so to say that, I don't believe that I'm ever going to see a population of dogs become a population of non-dogs. It's always going to be a population of dogs. So it might change. There might be drastic anatomical features that might change within that population, but there's still going to be a subset of dogs.
Is it because they're bringing forth after their kind? The law of monophyly? Is that why?
Well, that's actually just the law of evolution. I mean, that's just biological diversity. Like that's not coming after their own kind. That's just what we observe in nature.
And I would say it depends on your definition of evolution. I don't believe that is an example of, say, molecules to man evolution, fish to fisherman evolution. That's just an example of change in allele frequency.
We're talking about, if we're talking about biological evolution, we're only talking about the best explanation for the diversity of life. We're not talking about molecules to man. To get to molecules to what we would talk as like the first life out there has
abiogenesis. Yeah, I agree. Yeah,
that has nothing to do with evolution at all.
Well, I mean, you need that to have the coherent theory.
Right.
I mean, you need the life to start the allele frequency.
You need that, but there's no model that you can build to explain the diversity of life using evolution. Okay, that will also explain how the first life arose. Those are completely two different models, two different subjects of study.
Okay, well, what's the observable mechanism that adds new novel information to the genome then? Because if we started off as
first off, I mean, in that case,
there's a gene duplication. I mean, that's usually the answer I get. Is that what you're going to get to?
Well, I mean, so when we talk about the new novel information, there's a couple different ways that we do see this. Is that gene duplication is one of them, gene mutations. These things happen, and the information on what you get at the end result is different than what you had at the beginning. So that's a change in information.
Okay, but it's not a change in it's not an uphill change in information.
Well, no, that's what you're saying. But who says that it has to be an uphill change in information?
Well, because
evolution doesn't. You're not. You don't. There's no guarantee that every single change that you're going to be having in evolution is going to make you more, super powered. That you're going to be better, stronger, anything like that. What passes on in evolution has to rely on solely on the ability, the creature's ability to survive. Sometimes the successful populations within the successful populations, the animals that breed, the animals that pass on traits, might be animals that are smaller, faster than that. In that case, they might not be bigger, stronger, or anything like that.
Okay.
So those ones could be the ones that survive. So there's whether you want to say that it's an uphill battle for information, or there's an uphill gain of some sort. Well, that's not a representation of what what evolution is. There's a change in if you don't consider gene duplication or any type of mutation a novel change of information, then there's really no definition of information that you can use that would actually work there.
Well, because that type of evolution, large scale evolution, it's just not true. That's why no evolutionist can give you an answer. Because think about this, okay? Long hair versus short hair.
Didn't I just give you an answer? Like what can I give you an answer for that I didn't just say?
Well, because you're not giving me an answer. You're not giving me an observable mechanism that adds new genetic information. Because the thing is, let me just finish my thought here.
Are you asking for new anatomical features or new genetic information?
Obviously, new anatomical features aren't just going to pop out of existence. I understand that's not how it works. But over time, change in allele frequency in populations over time, it's going to have to at some point give rise to new anatomical, features. Because
over time,
population of dogs,
long period of time,
and there you go. So that's when you jump from empirical science into your religion. Because I would say it's a religion, because at the end of the day, you can't, what we see is dogs produce dogs. We know that. You say a dog today came from a dog, long ago and far away. Now you've left science and you've gone into your religion, because we don't see that. That is not part of empirical science. For example, let's take long hair versus short hair, change in dominant color, other variations. These are not evolutionary changes, but they're really just reshuffling of genes, okay?
But is that new information? If a new color is formed in a species of animal that wasn't there before, and that new color is beneficial to their survival, is that not new information?
No, it's not new information, because it's...
How is that not new information? How is it
a variation of pre-existing information? That information was already there.
But that color never existed within before within the population.
But the thing is, okay, so you want to say a different color of hair. If you actually look, that is based totally on a reshuffling of the genes that's in the existing gene pool.
Which would be new information. Reshuffling of something is new information. If there is a mutation within the genetics, if there's a duplication within genetics, if you want to call it reshuffling something produces new information that was not there before.
Well, it's not an uphill drift.
But I've already told you it does not need to be an uphill drift. Now you're going back to that point. Not every single change that, like I said, not every single change that we do observe within, within creatures needs to be some type of superhuman or super animal, beneficial type thing.
If you go back to models, this is why the biblical model makes more sense, because the biblical model actually predicts that we're going to see a variation in living organism. But the thing is,
okay, let's talk about the biblical model then. So how many animals were loaded onto the ark? Can you give me a ballpark number there?
Okay, so starting off, I'll give you the answer. Starting off in the biblical model, okay, we would say that the change in living things, it doesn't actually require new novel information, because we're going to look at this model right from the ground up here as well. So we're going to talk about the model that you have for the Noah's flood. There is that you have a series of animals that are loaded onto a boat. Now we know, because we actually have a full-size building replica that is building shaped like an ark that we can take a look at, and we can come to the conclusion very quickly that we're not going to fit every single a species of every single animal on that boat. So it's going to be a representative of every kind, and
right.
And seven of some. Yeah.
Right. So, ballpark figure. How many kinds of animals are there?
I think if you actually study the baraminology, obviously now we're going into historical science, and just like you couldn't explain how the non-dog gave rise to the dog, I'm not going to be able to give you.
I did that. I did that through changing the low frequencies over time and the reshuffling of information to produce new
Okay,
anatomical features.
and we're just going to have to agree to disagree. Reshuffling of pre-existing information is not new information. Gene duplication,
what about the duplication?
Existing information is not duplicating anything new. It's like me duplicating the same book.
Right, but you seem to be at this point in time, taking of what we would call in any other circumstances a new information. Like if you were to take like a deck of cards, okay, and you were to
reshuffle it.
We're going to play a game of war, and so we play a game of war, whatever. We take the same group of cards, we shuffle it, we pass it up there. We have a completely different hand. We have different. The game will play out in a completely different way. The information is all still there, but now everything about it is going to change. So the how is that not new information? But you know what? That's fine. Going back to the point. Let's talk about.
I mean, that is the point, because my point is the biblical model makes more sense of what we see, because we don't require new information, because God put a certain set of information in each kind of animal, and we varied since then.
Sure. Okay. Let's go with that then. Okay. So how many animals were on the ark then? Let's see how well this stands up. Give me a ballpark figure here.
Okay, so we're gonna start at the ark, not what God originally created. Like we're gonna start with the ark.
Just at the ark, because that is in your religious belief, that's a known bottleneck from there where we can take a look at things. Okay.
I don't know, maybe 6,000 different kinds. Maybe I could be wrong, but I'll say 6,000. We can start with.
Okay, 6,000. All right. So how many animals are on Earth now? How many different species of animal?
Oh, I don't know. I mean, you probably know the answer to that better than I do.
Billions?
Millions?
Yeah, 8.7 million. Okay.
Sure. Yeah, that makes sense. I can agree with that.
Okay, 8.7 million. Okay. Now, how many years has it been since the flood?
So the 4,000 years.
Okay. So in the last 4,000 years, to get from the original amount of animals that you had on the ark there, 6,000, to what we have now, we have to observe about 2,000 speciation events a day.
Well, what you're not understanding is
math. I don't know what.
I'll explain. So me, seeing things like genetic entropy, very consistent with obviously the law of increasing entropy, because according to the biblical model, there would have been the curse and everything would have gone downhill from then. That's what we see. The original representatives on the ark, they would have had such tremendous and significant genetic variation that the amount of variation, especially in that first, say, 1,000, 2,000, 3,000 years after, would have been amazing. I mean, those speciation events would have been tremendous. But the further we go from there and the more genetic entropy we see, the less speciation we're going to see. And you can see that in the fossil record. I mean,
so you're saying that the animals step off the ark, and because it's winded down, because we definitely don't see 2,000 new species being formed every single day now. That back in the day it was what, 10,000 per day. That I mean, okay, so like each day. So you have 6,000 animals. They get off the ark. They immediately have little baby ark animals after that, which would all have to be a new species. Okay.
Well, I mean, who's defining species? Obviously, you can have
Well, species right now, because we talk about the 6 point the number of animals now. Species in like the loosest way would just be the ability to breed within a population.
Yeah. Now, is speciation with
here's the problem. Okay. The problem for this is that while you deny like this change in low frequency and this new genetic.
Well, I don't deny. I understand that's the definition of it.
No, but you don't. Well, you don't like that. The only way that the Noah Ark model makes sense if you propose some type of hyperactive super evolution to produce that amount of variety of life in a short period of time. No, we
Okay,
don't
well,
observe that. So here's the thing. We don't observe the speciation happening at that type of rate at all. We have no evidence ever to see speciation happen like that. But we do have a model that we can work back to. We can see kind of the rate that the population is diversifying nowadays. And we can infer back from that that to get to the level that we're at now would take a substantially longer period of time than 4,000 years.
well, if I can kind of say something here, I would say, so obviously you're saying, it's a little silly that, all the dog variation we see today came from, say, 2 dogs on the ark, but you guys believe every animal we see today came from 2 animals billions of years ago. So at the end of the day, I may be jumping into my religion, when I jump in and try and explain Noah's Ark. But like I said, you're jumping into your religion as well when you're trying to say that we've all descended, universal common ancestry. It's the same thing. I mean, if you actually look at if you look at,
do it this way, then let's say it sounds like you don't really have a problem with evolution. You have a problem with common ancestry.
well, I don't have a problem with adaptive speciation because
Yeah.